Cardholder verification methods, concepts, implementations, and impacts is presented by the Communication and Education Working Committee of the EMV Migration Forum. This presentation was created in response to the many questions the committee has received about cardholder verification methods. What are they? How are they implemented? And how do they impact issuers, ATM owners, merchants, and cardholders? This presentation focuses on U.S. implementations and use of contact chip cards and contact chip readers. Although this presentation covers common scenarios, it is important for each industry stakeholder to confer with their payment network representative, processor, card personalization bureau, and other partners when making decisions related to cardholder verification methods, since business requirements and specific implementations may vary. In this presentation, we will review some basic concepts, issuer implementation considerations, terminal implementation considerations, and the cardholder experience as it relates to cardholder verification methods. We will summarize the presentation by providing some resources and references and by acknowledging the project team. In the context of a transaction, the cardholder verification method, or CVM, is used to evaluate whether the person presenting a payment instrument, such as a payment card, is the legitimate cardholder. An understanding of CVMs is critical to all stakeholders in the payments ecosystem. Issuers need to understand CVMs so they can decide which CVMs to support in their chip cards and in what priority order based on their business needs. Merchants need to ensure that their terminals can support the minimum CVM requirements for the major payment networks. Merchants also need to ensure that their staff can assist customers at the point of sale. Acquirers, processors, and value-added resellers need to ensure that their terminals support the minimum CVM requirements for the major payment networks. There are three categories of CVMs: PIN, signature, and No CVM required. The PIN can be either online PIN or offline PIN. These are not the only CVMs that are available, but these are the most common ones. Let's look at each of these CVMs in more detail. We are all familiar with the concept of online PIN. When using a chip-enabled debit or credit card at an ATM, the cardholder enters their PIN and selects the transaction they wish to perform. The PIN is encrypted, and the encrypted PIN block is sent online to a host system. The host performs PIN verification and transaction authorization and returns the response. We are using an ATM transaction in this example because we are all accustomed to entering our PIN at the ATM. It is also possible to use a PIN at the point of sale if both the card and the terminal support PIN. With EMV, it is possible to have the PIN verified between the chip card and a chip-enabled POS terminal. This is known as offline PIN verification. The cardholder enters their PIN at the POS terminal. With offline PIN verification, the PIN is captured by the POS PIN pad and verified by the chip card before the transaction goes online to the host. Let's say that the cardholder enters the correct PIN and it is verified successfully. When the transaction goes online for authorization, the request will not include the encrypted PIN, but will indicate that offline PIN verification was successful. The host will approve or decline the transaction, taking into consideration the result of offline PIN verification provided by the terminal, and the transaction response will be returned to the terminal. We are also familiar with signature as a CVM. The transaction request is sent online to the host, and the host authorizes the transaction. The response is sent back to the terminal. The cardholder then signs an electronic signature pad or a paper receipt. The merchant may or may not verify the signature. Merchants may allow cardholders to pay for their purchase without entering a PIN or providing a signature. In other words, no form of cardholder verification is required. No CVM is typically used for low-value transactions. It is also frequently used at unattended point-of-sale terminals. The only CVM that is allowed at U.S. ATMs today is online PIN. This is still true when using a contact chip card at a chip-enabled ATM. As we will see during this presentation, both chip cards and chip-enabled point-of-sale terminals can, and usually do, support multiple CVMs. Although the CVMs listed here are technically possible at point-of-sale terminals, it is not required or even likely that every US POS terminal will support every possible CVM. Chip cards and chip-enabled terminals can support more than one application identifier, or AID. Each AID in the chip card uses a CVM list to indicate the CVMs that are applicable to that AID. An AID can support more than one CVM. Not all AIDs support all or even the same CVMs. The CVM list is included in the chip card as part of the card personalization process. Chip-enabled terminals can support multiple AIDs. Each of those AIDs can support multiple CVMs. Now let's look at some considerations for issuers as they begin their chip card implementations. U.S.-issued credit cards will typically have one AID at this time. The CVM list for that AID will indicate whether the AID is signature preferring or PIN preferring at the point of sale. By preferring, we mean whether the signature CVM or a PIN CVM is higher in the CVM list. U.S.-issued debit cards will typically have two AIDs. Each AID will have a different profile, with each profile having its own CVM list. We will show another example of a U.S.-issued debit card later in this presentation. For more information about U.S.-issued debit cards, refer to the EMV Migration Forum presentation, Implementing EMV in the U.S., How the U.S. Common Debit AIDs Facilitate Debit Transaction Routing and Ensure Durbin Compliance. This presentation can be found on the EMV Migration Forum's website using the link shown here. Now let's review the logic that is used to decide what CVMs can be implemented on a chip card and the order of the CVMs in the CVM list on the card. In this example, our card will be used only at ATMs. The first step is to look at all of the potential CVMs listed here vertically and determine which one should be the first CVM in the list. Since Online PIN is the only CVM allowed at an ATM, Online PIN is the CVM that will be first in the CVM list. Next, we need to indicate the conditions under which that CVM will be used. All of the potential conditions are listed vertically. The only condition in this list that is appropriate at an ATM is for unattended cash, so that is the condition we will select. Now, we need to indicate what should happen if that CVM is unsuccessful. There are two options shown here in the third column. Since Online PIN is the only CVM allowed at an ATM, we cannot allow the cardholder to try a different CVM if the first one fails. So, we must fail cardholder verification if this CVM is unsuccessful. We now have our first CV rule for an AID on this chip card. Since this AID is only going to support the Online PIN CVM, our CVM list for this AID is complete. If the AID needed to support additional CVMs, this three-step process would be repeated for each individual CVM that will be associated with that AID. After all of the CV rules have been built, the individual CV rules are then combined to create a CVM list that is personalized on the chip card. Each unique AID on the card can have its own discrete CVM list. The chip card provides information about the CVM list to the chip-enabled terminal during the transaction, so the terminal is aware of the CVMs the card supports, the conditions under which each CVM is to be used, and the processing logic the terminal should follow if a CVM is unsuccessful. It is important to note that although the card provides instructions to the terminal on what to do if no CVM method is successful, CVM failure does not and should not result in an automatic decline. Instead, the terminal should follow the issuer's instructions about what to do when the CVM is unsuccessful, as configured in the chip. Processing the CVM is only one step in the transaction. How the CVM results are interpreted is also critical to a successful EMV implementation. Here is an example of a CVM list. This chip card supports online PIN at the ATM. For all other conditions, this card prefers signature at the point of sale, but also supports No CVM when requested by the terminal. Here is another example of a CVM list. The CVM list in this chip card also supports online PIN at the ATM. For all other conditions, the card prefers offline PIN when offline PIN is supported by the POS terminal, then online PIN, then signature, then No CVM, in that order. A U.S.-issued payment network branded debit chip card will typically have two AIDs, a global AID and a U.S. Common Debit AID. There will be two CVM lists, one per AID. This example shows a debit chip card with two AIDs. As you can see, the CVM list for the global AID is different from the CVM list for the U.S. Common Debit AID. Note that for a U.S. Common Debit AID, a licensing agreement may require that the CVM list contain a specific set of CVMs in a specific order, which may not be changed by the issuer. The major payment networks have established the minimum requirements for U.S.-issued chip cards and chip-enabled terminals. From the issuer's perspective, this means that at a minimum, the chip card must support the CVMs listed here. For example, all of the major payment networks require that a global credit AID support signature and No CVM at the point of sale. This does not preclude the issuer from adding other CVMs to meet their business needs. This chart is just a baseline. Refer to the Minimum EMV Chip Card and Terminal Requirements white paper from the EMV Migration Forum for more information. U.S. issuers have several important business decisions to make when selecting the CVMs for their cards. The card must meet the minimum requirements we saw in an earlier slide. The card must adhere to payment network rules. Issuers should consider how and where the card will be used. For example, if the card will only be used at ATMs. An issuer might consider supporting CVMs over and above the minimum requirements based on the portfolio or other business needs. EMV architecture provides a secure way for an issuer to update certain fields in a chip card post-issuance while the card is in the field, without having to reissue the card. Not all processors support scripting. Check with your payment network and processor for more information on this topic. Whether a chip card should be PIN preferring or signature preferring is the choice of the issuer. When considering whether to support additional CVMs, it is important to carefully evaluate business requirements against the cost and complexity of implementing and maintaining those CVMs, and the expected volume of merchants that may support those CVMs. For example, over 50% of U.S. POS terminals do not support online PIN today. We will talk more about this when we cover terminal requirements. Work closely with your payment network and issuer processor to understand all of the implications related to CVM support. For example, adding the PIN CVM is not a trivial undertaking. Here are just a few of the things you will want to consider when making this decision. Does the payment network have a lost and stolen liability shift? If so, and the POS terminal supports PIN, but the chip card is not PIN preferring, the issuer will not be able to shift the liability for lost and stolen fraud. Is the card portfolio experiencing a high amount of lost and stolen fraud? Does the card portfolio include international travelers or military personnel who may frequently use their card at terminals that accept a PIN? Is your organization able to support PIN? This involves more than just the ability to carry the PIN in the online transaction request and verify the PIN during the authorization process. You will need to support customers that forget their PIN. There may be Know Your Customer challenges for setting the PIN for authorized users. You will need to provide a way for customers to change their PIN either at the ATM, in the branch, through IVR, or other methods. You will need to understand the various payment network requirements related to online PIN and offline PIN, including offline PIN management. And of course, you will want to consider the customer experience. Now let's look at CVMs from the perspective of the terminal. As previously noted, the major payment networks have established the minimum requirements for U.S.-issued chip cards and chip-enabled terminals. From the terminal owner's perspective, this means that at a minimum, the chip-enabled terminal must support the CVMs listed here. As an example, for attended point of sale, signature must be supported. Support for PIN or No CVM is optional at attended point of sale. The decision about which CVMs to support is made by the acquirer processor and the merchant. At unattended point of sale, the terminal must support No CVM and ATMs must support online PIN. This does not preclude the POS terminal owner from supporting additional CVMs to meet their business needs. This chart is just a baseline. Refer to the Minimum EMV Chip Card and Terminal Requirements White Paper from the EMV Migration Forum for more information. Also check with the various payment networks and your other partners for their suggestions and recommendations. Let's walk through an example of how the CVM that will be used for a transaction is actually selected when a chip card is used at a chip-enabled POS terminal. At this point in the transaction, the AID to use for the transaction has already been selected. The card in our example has 4 CVMs in its CVM list for AID 1. The terminal supports signature and No CVM. The first CVM in the card's CVM list is online PIN for unattended cash, in other words, at an ATM. But we are at a POS terminal, which does not support this CVM, so this CVM cannot be used for this POS transaction. The terminal then looks at the second CVM in the card's CVM list, which is signature. The terminal does support signature, so there is no need for the terminal to look further down the card's CVM list. Signature will be used for this transaction. Remember that although the card provides instructions to the terminal on what to do if no CVM method is successful, CVM failure does not and should not result in an automatic decline. Instead, the terminal should follow the issuer's instructions about what to do when the CVM is unsuccessful, as configured in the chip. Processing the CVM is only one step in the transaction. How the CVM results are interpreted is also critical to a successful EMV implementation. Let's use the same card again. You stop to buy a cup of coffee on your way to work. For certain low-value transactions, the POS terminal may default to No CVM if No CVM is supported by the terminal. For attended point-of-sale terminals, the decision to default to No CVM for low-value transactions is the choice of either the merchant or the merchant acquirer. A merchant that supports PIN may allow a cardholder the opportunity to opt out of entering their PIN, for example, if the cardholder has forgotten their PIN. This is known as PIN bypass. For more information about PIN bypass, please refer to the EMV Migration Forum's white paper on this topic, which will be available shortly on the EMV Migration Forum website. Merchant considerations related to which CVMs to support may vary by industry vertical, by customer needs, and by interchange considerations, although interchange fees and rates do not change for EMV. Merchants need to understand that some payment networks have a lost and stolen liability shift. If the chip card prefers PIN, but the terminal does not support PIN, and the transaction is later deemed to be lost or stolen fraud, the merchant or the acquirer may be liable for the fraud. Merchants will need to assess their level of risk. Restaurants may not wish to support PIN unless they have pay-at-the-table capability. Consider the feasibility of having a PIN pad available for the customer. There are many things a merchant will need to consider if they do not support PIN today, but are thinking about supporting PIN in the future. The merchant must consider the requirements of the various payment networks they are affiliated with. The terminal must be upgraded to add a PIN pad. Internal testing and recertification will be required. Clerks must be trained to assist customers, and each merchant must define their PIN bypass policy. Now let's talk for a moment about the cardholder experience. The cardholder experience at the ATM does not change as far as the CVM that will be used. Online PIN is still the only CVM allowed at ATMs. At the point of sale, the customer will be prompted if a signature or PIN is required. This is based on the CVM that is selected according to the CVMs that the chip card and the chip-enabled terminal support. For low-value transactions, no CVM may be required. It will be important for cardholders to watch the terminal screen for messages and prompts that will guide them through the transaction. Additional information about the cardholder experience can be found on www.gochipcard.com. We hope this presentation has been helpful. We realize that some of the concepts presented here are complex. For more information about the topics we have discussed, please refer to any of the sites listed here. The EMV Migration Forum wishes to thank the project team and others who contributed to this presentation. Thank you for watching this presentation. To learn more about the EMV Migration Forum, please contact us.